Hey, welcome back. In example 3, we want to find trig ratios given another trig ratio. So in A, we're asked to find the sine of theta when cosine of theta is equal to negative 2 root 7 over 7, and theta is between pi and 3 pi over 2 inclusive. So if you remember from radians on your circle, that we start at 0 and 1 full revolution around the circle is 2 pi. So halfway around the circle is pi. Half of that is pi over 2. And so this would be 1 pi over 2, 2 pi over 2, which makes this one 3 pi over 2. Then back to 4 pi over 2, which is 2 pi. So for theta between pi and 3 pi over 2 puts the terminal side in quadrant 3. So this range of values tells us that our terminal side of our angle lies in quadrant 3. Okay, and that's significant because we know that in quadrant 3, both the x and the y are negative. So when we identify the x, y, and r using the trig ratio that we're given, we're going to need to recall that the signs of both x and y are negative. R is always positive. So if cosine of theta is negative 2 square root of 7 over 7, and cosine is x over r, then that makes the numerator the x and the denominator the r. And since r is positive, we know x has to be the one that has that negative value. So x is equal to negative 2 square root of 7. And the y we need to find. And we know the r, the radius, is equal to 7. So now we're going to look for the the y. We know x and r. And using the Pythagorean Theorem, we can find the y by taking the square root of the radius squared minus the x squared and those formulas are on the front of your notes booklet if you are looking for a reference. So then remember there's a plus or minus in front of here. And we have the square root of 49 minus negative 2 times negative 2 is 4. And square root of 7 times square root of 7 is 7. So then we've got the square root of 49 minus 28, which is 21. And we, from our range that we were specified from pi to 3 pi over 2, we figured out already that the y is going to be negative, so we discard the positive answer, and the y is equal to negative square root of 21. So now to find the sine ratio, sine is defined as the y over the r. So the sine of our angle theta, which we know is in quadrant 3, is equal to negative square root of 21 over 7. Okay, so go ahead and pause the video and try example B on your own, and then when you're ready to go over it, we can resume. Okay, so welcome back. Hopefully you just give example B a try. Here we're told that the cosine of theta is less than 0. So cosine has to be negative wherever this angle is. And in our quadrants, in quadrant 1, x and y are both positive, which would mean since the radius is always positive, cosine would have to be positive in quadrant 1 because cosine is x over r. So in quadrant 4, the x is also positive, so cosine would be positive in quadrant 4. So if cosine is negative, then that means we're either in quadrant 2 or quadrant 3. But because we see here that the sine is positive and the cosine is negative, that means we have to be in quadrant 2 because sine is y over r, which to have a positive sign means that the y value had to be positive. So the only quadrant where the y is positive and the x is negative is in quadrant 2. So that tells us then that the x is going to be negative, the y and the r are both positive, and sine is defined as y over r. So now we know that the y is positive 8 and the r is positive 17. So we want to find the x, and just like we did in example A, we're going to use the Pythagorean theorem to do that. So our x is going to be equal to the square root there we go, the square root of the radius squared, which is 17 squared, minus the y value squared, and that's going to be x equals plus or minus the square root of 225. And 225 is a perfect square. So x is equal to negative 15. And we're keeping the negative, not the positive, because we are in quadrant 2. So x is equal to negative 15, and tangent is what we're looking for. Tangent is the ratio of y over x. So the tangent of our angle theta is 8 over negative 15.